That is our Y4.
So, sir, just a
Yeah.
question.
Yep.
Based on my understanding, this is geometry, right? It's purely geometry. Solving by geometry, right?
That's what again?
You're solving it by geometry, right?
Yep.
So why is it that I can't just draw it accurately and then pull the numbers from there? Like, why is that a concern?
You mean your drawing can tell me it's 4.57 KSI? Your drawing can tell
Because
me.
I could tell you're gonna get 4.5 around there because you drew the
No.
line.
3 decimal point, sunshine.
Sir, yeah, how much marks we take off for something like that? That's my question. Because you might be in a crunch, you know.
Andre, listen to me. Okay? Be obedient. The circle is just a teaching aid so that you know whether your answer is right or wrong. You need
I
to
know
calculate
you
3
mean, sir.
decimal
I
point.
understand. But
Okay,
I think that your method's pretty foolproof. So I'm like,
okay, you can
calculations are more
calculate
of a
4.57, Andre.
uh
Can calculate 4.57?
I could probably get it if I draw a good graph.
Yeah, you draw a very big circle, yes?
Yeah.
Andre, hey Andre, come to McMaster, I'll give you a hug, you cheeky sod.
That's old school engineering, sir, right? Drawing on paper, right?
Huh?
The old school engineering. That's how they used to do it. They draw on paper. Didn't
Yeah,
have softwares.
yeah. We are not more, you are not that old, you are young, you cheeky sod, Andre.
All right, sir.
Okay. Why? Yes. Ask now. Huh? No. You ask. You pay school fees, you ask. I'm coming there now, you cheeky sod. Question for you, is this answer right or wrong? Andre, my drawing guy, is this answer right or wrong?
What? If the answer is right or wrong?
Yeah.
What plane was this you drew for?
Huh?
XY plane? I'm not sure. I don't know. It looks right. Your
It looks
drawing is
right,
right.
right? Right. The answer is wrong.
Your drawing is right, but the answer is wrong. Yeah. I don't know.
Yeah. The answer is wrong. Why? Because this circle is very interesting. This circle alone is a 3DMohr circle. Why? All the 3 points are on the same what? Circle. So this circle represents XY plane. This circle represents YZ plane. And this circle represents XZ plane. So it is possible for a 3DMohr circle to be a single circle. Isn't it? It's possible. Right? So you look over here, right? So XY, one circle, right? Then we have point Z. ZX, when we draw, is also what? The same circle, right? Point Z and point Y, we draw also on the what? Same what?
Circle.
Yeah. So this is really, really interesting. It is possible. So next time you can ask anyone, any of your chief engineer in any company or any university, is it possible to have 3DMohr circle under one circle? And they will say, no, it is possible. But why is this answer not valid?
Sorry, Eugene, I didn't get that. Why? What 3 circles the same? Can you explain again?
XY plane is on the same circle. YZ plane is on the same circle. XZ plane also on the same circle. So it's possible to have a 3DMohr circle to be under one circle. Ali, does that make sense now? Hello?
Yeah, I'm just thinking.
You're just thinking. Right? I cannot draw any other circle, can I? Okay, like a cube. No, it's not like a cube. Nothing like a cube. Okay, so this is not valid because tau max is not equal to 10 KSI. Okay, tau max is not equal to what? 10 KSI. For this simple reason. Okay, are we clear? Right? So I've shown you 4 possibilities. The trick is this. I also show you why 2 are correct and why the other 2 is what? Wrong. It's important not just to know the correct answer. You have to know why other possibility is not what? Valid. Are we clear? Okay. That makes you perfect engineers. Okay. Let's say you calculate something and you realize like this might not be right. You have to prove why it is not right. Okay. Okay.
Sir, how did you find out that the other planes are on the same circle?
Because you look, I draw one circle, all the 3 points are on the same circle. Abdullah or Abdullah.
Assad, sir, you can say Assad.
Yeah, right? All 3 circles are all 3 points, X, Y, and Z, or stretch Z, all are on the same point. Oh, sorry, all on the same point. All of them are on the same circle.
Can you go to the one above, sir? The circle above? Just so for
Say it again, Andre.
the previous working out scenario.
What about the previous scenario?
Okay.
Andre?
No, just say something. Okay.
Oh, you're trying to see the trend, yeah?
Yeah.
So when we started drawing this circle, we started with this line that I highlighted. Can you see that, Andre?
Yeah.
Then why there's another possibility? Okay, some student asked me, Eugene, what if we draw this first? Is the answer valid? That's why whenever you're asked question, it makes me think why this is not valid, because I take it for granted and you guys are making the course better anyway. Can you see that? How we start? Yes or no, Andre?
Yes, sir. Yes, sir.
Yeah, makes sense, yeah? Okay, good, okay. We are going to do, yes. No question on the test. You have to show me the correct one. I will show you what is not the right one. Why will you answer me when you know something is wrong? Yes. Yeah, the numbers are different. But if you do 1 and 4 for me, you got 0 mark. Yeah. Yeah, you get mark. If you do 1 and 4, you just show me what is not right. How am I going to give you your mark, you cheeky sort? I'm just teaching you as an engineer, you can prove why it's not correct that way, okay? Or sometimes you forget, right? You draw this first and you thought your answer is right and then, oh no, this answer is not. Then you can erase or cancel and then put in the right answer. Good question also, okay? Right. Next, we are going to do another problem, okay? This problem gives a lot of students a lot of problem. That's why I want you to look at this problem. I tell you, when you finish from this course or this class, you will be known as a Mohr circle expert. I'm serious. I'm not bullshitting you, okay? Because you're learning from the best. Now you're hearing bullshit from me already.
Sir, will the exam have 2 questions?
Huh?
Will the exam have 2 questions?
Don't know yet.
Okay.
Don't ask me about the exam. I'm teaching, okay? I haven't said the question yet. Okay. This question is a very, very interesting question, okay? So I've posted all this on Avenue to Learn. I want to focus on this question, okay? Okay, so this question is a column, right? And it has a load coming down, P, Okay. And then it states that at angle and in the plane AA, the measured stress is minus 15 and the shear is 5 KSI. Okay. Determine the angle beta and also the maximum compressive stress in the poles. Okay. So we are going to do that. Okay. So you can see the solution. They do that. Okay. I'm going to use the rules of the circle also to solve this problem. And I want you to focus on why. I want you to focus on the stress state of the element. That is most important. Okay. I repeat again. I want you to focus on the stress state of the element. Okay. Now, first, I'm just going to sketch the structure for you. So we have a structure down here. We know that the structure have a load P, and over here we have a cross-sectional area, which we call A. Okay. And then at a certain plane orientation, and this angle over here is what they call alpha or beta. Right? And we have values of minus 15 KSI and 5 KSI. Okay. So I'm going to call this X and Y. Okay. I'm going to call that X and Y. So we draw one element at 0 degrees. Okay. We know that there's a normal stress coming down, and this is P over A. Okay. So from here, we know that stress X is equal to 0, stress Y is equal to P over A, shear XY is equal to shear YX is equal to what? 0. Okay. So we are aware that this is the principal plane. Okay. Shear stress is equal to what? 0. Now we put an element down here. Okay, we put an element down there. The element is rotated at beta angle. Okay. They state that the 15 is going through compression. This is easy. Now, the shear, is it going up or going down? Right?
No.
Yeah. Where are you? Andre, Aliva, you are correct. It's
Yes.
going down. Why? If this thing can slide downwards, right? It's going to slide downwards this way, yes or no? It's going to go down this way. Yes? So it is what? Going down relative to what? P, yes or no? It cannot go up. It has to go down. Right? It cannot go up. It has to what? It has to go down due to the P. If you draw up, it is wrong. How can the shear force going up when the structure want to flow down? So that is why you construct the shear stress this way. Hey, nothing to memorize. All is analysis. Yes or no?